matrices. We're talking about matrices, covering matrices today. We've talked about matrices before. We've done these before, but we're going to go a little bit more in depth in some ways. Now, a matrix is a rectangular arrangement of variables or constants. And we've talked about these before, rows and columns. Now, one thing that we didn't really talk too much about is elements. Each number inside a matrices is an element. So 8, -2, all these numbers in matrix A are elements. Now, we always denote the matrix by a letter, and it's going to be a capital letter. So we'll call it matrix A, capital letter A, or B, capital letter B, C, D. Whatever we call the matrix is always going to be a capital letter. Now, their elements is going to be the lowercase form of that letter. So since this is matrix A, each element is going to be denoted as lowercase a. And the two numbers next to it are the row and column. Row is going to go first, column second. So if we talk about second row, first column, we're looking at the number -1. And we have these here. And the other one they have is A32, third row, second column, would be our -8. And dimensions are just the rows by columns. So if we look at this first one here, because we've talked about dimensions before. So for this here, use matrix A to answer the following questions. So the first thing we want to do is state the dimensions of this matrix. It has 2 rows and 3 columns, so it is A2 by 3. So that's the dimensions of matrix A. Now the other thing they want us to do, and what we're going to do, is find element A21. First number is the row, so here it's looking for row 2, column 1, which is 9. Second row, first column, 9. That's it. Questions on this here? All right, let's look at another example of this here. So we have matrix B. All right, guys. So we want to state the dimensions of matrix B. It is a 3 by 2. All right, guys. Up here. Here we have 3 rows. And how many columns? 2, so it is a 3 by 2. So element B32, so we're looking for the number that's in the third row, second column, which is -1. With this here, if we said B22, which would be 19, second row, second column. If we said B12, first row, second column. Do we kind of get how this works? Yeah, because everything works, or we always start in that top left, which is 1, 1, and we can go from there. Down and then over. All right. Now we do have some special names for certain types of matrices. The first one that listed has exactly 1 row, so it's a row matrix. The second one has exactly 1 column, so we call it a column matrix. The third one, the number of rows and columns are the same, so we call it a square matrix. It looks like a square, because we can actually have 7, -8, 4, 3, 0, 5, 15, -7, 2/3. This here is a 3 by 3. It's still a square matrix because the rows and columns are the same. Is that a square matrix? Yeah, rows and columns are both 1, so it is a square matrix. Last one we have up here is the 0 matrix. Every element in the matrix is 0. We have one left, or one that's not mentioned. It's the identity matrix. In the identity matrix, everything is 0 except for our diagonal ones going from left to right. That's the identity matrix. So you have a diagonal of 1s from top left to bottom right, and everything else is 0. This is the identity matrix. Questions on this here? Next thing we're talking about is addition and subtraction. We've done addition and subtraction before. We've talked about this before. To be able to add or subtract two matrices, the dimensions have to be the same. They have to be the exact same. So if we look at this here, A plus B, well, matrix A, what is its dimensions? It's a 2 by 2. B is a, are the dimensions the exact same? But not C. So here, we can add A and B. So 16, 2, negative 9, 8. And we can add to it negative 4, negative 1, negative 3, negative 7. We're just going to add these two together. And again, when we add two matrices together, we add the corresponding elements, the numbers or elements that line up. So 16 plus negative 4, 2 plus negative 1, negative 9 plus negative 3, and 8 plus negative 7. Now 16 plus negative 4 is 12, 2 plus negative 1 is 1, negative 9 plus negative 3 is negative 12, and 8 plus negative 7 is 1. So we just add those corresponding elements and we are done. Questions on this here? We good with this one here? All right. So we need to add the following, or here we're going to subtract B, which is negative 4, negative 1, negative 3, negative 7. And we're going to subtract C from it. So we're doing B minus C. The dimensions are not the same, so we can say this is not possible. And as much as we want to say no solution, it's not going to be no solution because we're not actually solving for something, we're simplifying. It's just we can't subtract these, it's not possible. Questions on this here? Do we feel pretty comfortable with addition and subtraction? Because it's just add or subtract. Now we could do these in the calculator. Because the graphing calculator, we can do this, but the first thing we have to do is plug the matrix in. So the first thing to do for that is we're going to go second matrix. And then we have to go over to edit, and we'll hit enter for the first matrix. Now our A matrix that they gave us is a 2 by 2. And we'll do 16, 2, negative 9, 8. Because we're going to type that first matrix in. We type each element in. And once we get finished typing it in, second quit. Now we need to type matrix B in. So we'll do the same steps. Second matrix, over to edit and down to B. Yes. So go over to edit, enter, and we type. Yeah, so we have to edit, and you can hit enter, and it'll move over to the next spot. So we can do 2, enter, 2, enter, and it'll change the dimensions to that there. So I'm going to type matrix B into the calculator for matrix B. -1, -3, -7. Second quit. Because to quit out, we have to quit out each time. Otherwise, it's going to try to type the next thing into that matrix. Now, once we got them all typed in, we can recall these matrices by going second matrix. This list where it says names lets us recall it, lets us use these matrices however we want. After you finish typing it in. And if I enter, it'll pull up matrix A, because the problem that we're on says A plus B plus A. So we can say matrix A plus second matrix will go down to B plus second matrix A. And that's our answer. Now, especially with addition and subtraction, we could probably do this addition, subtraction one by hand about as quickly as we can doing it in the calculator. We're really not saving a lot of time with this here. Because really the first main steps is just getting it typed in and going from there. Any other questions on addition or subtraction? Scalar multiplication. When we talk about scalar multiplication, we take whatever the scalar is and multiply every element in the matrix by that scale. So here, we're multiplying the matrix R by 5. So every element in this matrix is going to be multiplied by 5. We'll have 5 times -12. And then 5 times 8. And then 5 times 6. And we'll have 5 times -16. 5 times 4. And 5 times 19. We're just multiplying every element in that matrix by 5. Because that's our scalar. That's what we're saying with 5R. Now, the last thing we need to do is just do this multiplication. So we'll do 5 times -12, which is -60. 5 times 8 is 40. 5 times 6 is 30, yes. 5 times -60 is -80. 5 times 4 is 20, and 5 times 19 is 25. That's it, because when we multiply by a scalar, we're just multiplying everything in that matrices by said scalar. Now we can actually do that in either calculator. We can put the whole thing in the the graphing calculator and have it calculated out. Or you can just multiply each number by 5 in the 30xs. Both will work. Questions on this here? Because, again, we could do this in the calculator, the graphing calculator, because the first thing we're going to do is second matrix. Second matrix, we got to put it in. Then we're going to go over to edit. Now, since we're only putting one in, we'll just put it in as matrix A. Now, matrix C, the dimensions of this matrix are a 2 by 4. And we have 8, 0, 3, -2, -1, -4, -2, 9. Second, quit once we get it typed in. Now, the problem wanted us to find -4 times our matrix. So the first thing we'll type in is -4. Now, you're good. Now, we don't have to put times. We can just recall the matrix C that we defined it as, which was A. So second matrix, enter, and it'll give us the matrix C here. negative 32, 0, negative 12, 8, 4, 16, 8, negative 36. Questions on how we got that there? Okay. Only other thing we can do with scalars in addition and subtraction as well, we do them together. We do them at the same time. So we have negative 4 times v minus 3 times a. Now before we start adding or subtraction, we have to apply the scalar. Well, for the first one, all that means is we're going to multiply everything by negative 4. Now we can write it out. There's nothing wrong with that. Or we can do negative 4 times negative 4, which is 16. Negative 4 times negative 8 is going to be positive 32. Negative 4 times 2 is negative 8. And lastly, negative 4 times negative 3 is 12. So again, we could do that already. We can be multiplying them as we simplify. We don't necessarily have to rewrite it as negative 4 times negative 4, negative 4 times negative 8, negative 4 times 2, negative 4 times negative 3, and then simplify. We can do that in one step. There's nothing wrong with that. Now the next thing is applying the 3 to the second matrix. Now we can multiply it by 3 or multiply it by negative 3. Now if we just multiply it by positive 3, the last thing we'll have to do is subtract. But if we multiply 3 by negative 3, we took the negative with it, which means we're going to end up adding the two matrices together. So I'm going to multiply through by negative 3. Now negative 3 times negative 9 is going to be positive 27. Now negative 3 times 12 is going to be negative 36. Negative 3 times 2 is going to be negative 6. And negative 3 times negative 16 is going to be positive 18. Questions on how we got to this point here? Now at this point here, we're going to add our corresponding spots. So we can do 16 plus 27 is 43. Then we can do 32 plus negative 36, which is going to be negative 4. Negative 8 plus negative 6 is negative 14. And lastly, 12 plus 18 is 30. So we don't have to rewrite it after each step. We can go on and just do those steps together. Previous page. Yep. Mm-hmm. Yeah, because if the way you typed it in would have worked if you put the 3 as positive with the subtraction. Yeah, and especially when you type it in, I type it in kind of as you see it. Negative 4b minus 3a. That way the negative doesn't throw you off. Now again, just like before, we could type this one in and gotten the answer. But the first thing we have to do is actually put those matrices in. So we'll go second matrix edit. Now we're not looking at a 2 by 4 anymore. We're still looking at 2 by 2. So we'll have negative 9, 12, 2, negative 6. And once we get that typed in, we'll go second quit, second matrix. Over to edit, but since we're putting a second one in, we'll need to make sure we go to B. It's a 2 by 2, -4, -8, 2, -3. And once we get them typed in, we'll just type it in, -4, second matrix B, -3, second matrix A. 43, -4, -14, 30. Same thing we got. I throw that on the floor. Questions on how we got this here? We're good with this so far? All right. Now, most of all this, except for kind of the elements we've covered before, we have not talked about matrix multiplication. Now, to be able to multiply two matrices together, the columns of the first has to match the rows of the second. The columns of the first matrix have to match the rows of the second for us to be able to multiply, because if they don't, then we cannot multiply them together. Interestingly enough, the dimensions of the matrix C, when we multiply them together, and they are able to be multiplied, are given to us by the rows of the first, columns of the second. So, if we look at this first example here, A times B, the columns of the first is 4. The rows of the second one is 4. So can we multiply these together? Are these two the same? Yes. So yes, we can multiply them together. Now our product of A times B, the new dimensions, will be the columns of the first, rows of the first by columns of the second, which would be a 3 by 2. So we multiply a 3 by 4 by a 4 by 2. Our new product will be a 3 by 2. Questions on the first one here? Let's look at the next one. Columns of the first is 3. Rows of the second is 5. These are not the same, so we can't multiply these together. Let's look at 1A. Columns, rows are both 6, so yes, we can multiply. And our A times B, our new dimensions would be what? 4 by 2. 4 by 2. Can we multiply 1B together? Columns of the first is 2, rows of the second is 3. They're not the same, so no. Questions on this here? What if I said A is a 99 by 1 is being multiplied by B, which is a 1 by 99? Yes, because the 1 and 1 match. So what would the dimensions of AB be? 99 by 99. That'd be a square matrix, yes? I'm going to flip it. Let's say B, which is still a 1 by 99, is being multiplied by A, which is 99 by 1. Can we still multiply these? Well, yes, because our 99 and 99 match, yes? So BA would be a 1 by I think that's kind of interesting because here A times B gave us a 99 by 99, a matrices that has 99 rows, 99 columns. That thing is going to be huge. We flip it, still able to multiply, but it's gone from a 99 by 99 to a 1 by 1, a single number. It is interesting how this works. So that means matrices are not closed under multiplication. A times B is not going to be the same as B times A. Order matters. Now, when we multiply two matrices, there is an order in which we multiply. There is a pattern to this here. And I call it, or kind of refer to it as over and down. Because we take the first row and multiply it by the second matrice's first column. We're multiplying over and down, and the corresponding elements multiply together, and then we add those multiplications together. So we have A times E plus B times G. And we would keep going. If there was an element after B in the first matrix, we would multiply it by the element below G. And after we do that multiplication, we'll keep going through every column in B. We're going to go over, down, over, down, over, down. Oh? Yes, it is repetitive. But once we finish with the first row with all the columns, we move down to the second row. And we do the same thing. Over and down. Over, down, over, down. So if we look at this here, and do x (6, -3, -10, -2), and we multiply it by -5, -4, 3, 3. If we multiply these out, we're going to go over, down, over, down. So, first thing we're going to do is go over and down for this here. So for us here, we're going to do 6 times -5. And add to it -3 times 3. Over and down. Questions on this so far? Then we're going to do this again. 6 times -4, yes. Plus -3 times 3. So questions on this here before we move on to the second row. So we do this with the first row each and every time. So we go over, down with the first row, first column, then first row, second column. If the second one had a third column, we'd do it again. We'd keep doing it for every column the second one has. And then we move to the second row and do the same thing. -10 times -5 plus 2 times 3. And we do it one last time. Questions on how we did this so far? Now we need to simplify this. So you could type each one of these into the calculator. 6 times -5 plus -3 times 3. If we did this by hand, -5 times 6 is -30. -3 times 3 would be -9. So we get -30 minus 9. 6 times -4 is -24. -3 times 3 is still -9. Negative 10 times negative 5 is 50. Negative 2 times 3 is negative 6. Negative 10 times 4 is 40. And negative 2 times 3 is negative 6. Negative 30 minus 9 is negative 39. Negative 24 minus 9 is negative 33. 50 minus 6 is 4. And 40 minus 6 is we agree. Because I think you typed it in and let the calculator do it first. Yeah. The calculator can do this just fine. I think this, out of everything we've covered today, multiplication is really one of the first ones that the calculator can do it a little bit quicker than we can. Questions on this here? We feel comfortable with matrices, at least multiplication. Because I can show you this here, especially typing it in. Because if we type this in, the first thing we got to type in is A. So second matrix, over to edit for A. It's still a 2 by 2, so 6, negative 3, negative 10, negative 2. Second quick, second matrix, over to edit for B, 2 by 2, negative 5, negative 4, 3, 3. Second quick. Now to multiply, we can call second matrix A, second matrix B. We don't have to put a symbol between them. It just understands that we're multiplying. You could do matrix A and then do times matrix B. It will do it still. But we get this here. Now I'm going to flip it and say B times A. Now we already seen one example with the 99 by 1 and 1 by 99 that they gave us two different answers. Here, if we multiply B times A, it is still a 2 by 2, but yes, all the elements are completely different because that multiplication's changed what we're timesing everything by. Questions on this here? Questions on anything we've done so far? Now I'm going to go on and do a matrix C, which is going to be a 2 by 2, 0. So this here is a 2 by 2 of the identity. Everything else is 0 except for that diagonal of 1. Second matrix A, second matrix. So now I'm going to multiply A by the identity. Well, matrix A was 6, negative 3, negative 10, negative 2. It gave us the matrix E back. And one of the other interesting things with the identity is if I go matrix C times matrix A, we get the same thing. Multiplying by the identity is the equivalent of multiplying by 1. It is the identity. The multiplication of 1 is our identity property for multiplication. Yep. One more time. Yeah. Yeah. That's one of the nice things with the identity matrix. So, your homework is a worksheet. There are 26 problems on this here. But luckily,